Thank you to the Chairman, Dr. Professor Datta. Thank you to the Aqua Foundation for inviting me to give this talk. And greetings to all of you from sunny South Africa. It's a long way from here, but I'm happy to be here to share with you some things we are doing to reuse water. There's not much technology in what I'm going to speak about, but it's very simple, but the things that we have to pay attention to if we want to get water in the future. You can see the little background to this, that the next world war may be fought for on the basis of water and not of oil. So that is a very important point, and this paper is focusing on using and reusing water from industry mainly, because industry uses a lot of water, and one industry which we are touching on is the dyeing industry. Not dyeing in the sense of not living, but dyeing in the sense of putting color to everything that we need in this world. All of us human beings seem to like colorful life, and we use color in all kinds of things, starting with food and cosmetics, which we use to decorate our bodies and so on. But that's another story. I'm not going to go there. But just what are dyes? They are colored substances. I think all of you know that. But just to point out that there are some things we should know about dyes, and the fact how dyeing is done. There's a little bit on this slide here, and I'll move on because all of this I think is known to you. And where do we get these dyes from? And the sources I want to say mainly, one is nature, and the other one is from industry. So there are two ways in which we can get dyes. And nature is kind to us because it does not pollute the water, because the dyes that come from natural material are not toxic to the water source, so therefore that is not a problem. Then the manufactured dyes, just for interest, the first dye was made in 1856 by W.H. Perkins, a chemist, but he didn't make it deliberately. Serendipity was involved here. He made it by accident. He was trying to make something else. As in chemistry, we have an idea that we're going to make one compound, then we're happy that we make another compound on which we can publish a paper. That's the life of a chemist. Anyway, without going further to what dyes can be classified in many ways. As you can see, I've just put down 3 ways in which we can classify dyes. Now, for those who are chemistry inclined, this is the structure of a dye. You can see there's many carbon atoms in the dye and the other things involved. They are linked. But what I want to touch on is this link here. This one in blue. For those of you who know a little bit of chemistry, there's a double bond between 2 nitrogen atoms. This group is called an azo group in chemistry, and this group here is responsible for cancer in many compounds. So if you see this azo group, so lights must flash. So that's all I want to say there. Now we want to get these dyes out of water. Now let's go back a little bit. The water is polluted by many chemicals. Some of them we can see, others we cannot see. Now those that we can see are offensive to our eyes, but those we do not see are offensive to our bodies. So, but that's another story. I'm not going to go there at all. So chemists, they analyze water. The ones that you can see and the ones you cannot see, they analyze for both of them. In this case, I'm only going to touch on the dyes which we can see, and we're going to try not to take out the dye by using chemicals which will cause more pollution. So the idea is to take out the dye without adding more problems to the situation. So this is called green chemistry. So the emphasis is on using as much as possible something that is close to nature and is not going to give our bodies problem in the future. Now, there are many ways of doing the dye. We'll go back to the first one. That is, you can use substances, very simple substances, even feathers from chicken, or you can use rice husk, which you throw away. All of these materials will adsorb the dye. In other words, they will take up the dye, and you can easily filter these things because they are solids. You can filter them from water. Water is a very small molecule, so it goes through very small pores, so even a crude filter can take out all of these kind of materials which can be adsorbed onto solid material. The next one is that instead of taking it out of the water, you can convert the dye to something which is not offensive, not harmful to anyone. So in other words, there are lots of chemicals in water which are not offensive to us. In fact, we shouldn't kill all the things in the water because the water will be useless to us. Because nature has put in some things, there are organisms in the water which we should not kill by trying to make the water clean for us to use. So the one method that occurs to us is to convert the dye into harmless material. So this is the focus of what we are doing in this piece of research, and that is one aspect is to use nanotechnology. Nanotechnology means you make materials which you cannot see, very difficult to see even with a microscope, so you need special devices to look at the nanoparticles. They are very small. So these nanoparticles adsorb, you can use them for adsorption, and you can also filter them out of the system. Again, now we concentrate on the fact that you can synthesize the nanoparticles by using green chemistry. In other words, we take a platinum compound or any compound that is a metal compound. We reduce the metal from a high oxidation state to zero oxidation state. That means it becomes metallic, elemental metal, but it is small enough. And the reason why the metal particles should be small is that physics tells us the smaller the particle, the greater the total surface area of the material that you're using. So therefore, you increase the surface area, you increase the area that's available for adsorption. So it's a very neat and clean idea. But to make those nanoparticles, one should use not other chemicals, but use what nature gives us. And we use a variety of natural material. One that's available in South Africa is the fruit called amarula. Some of you know they make a very nice drink out of that amarula and they sell it. But I'm not going there. We're going to use the fruit, or we can use equivalents of that to make nanoparticles. Here I'm going to just now talk a little bit about one element in the platinum group of metals, and that is palladium. We have used palladium, and we have used a very common material, that is the moringa tree. I think all of you know what this is. It's available plentifully in India. It's available in South Africa because Indians took this tree or a plant or the seed from India, and when they went to in South Africa, and there's now plentiful supply of moringa trees. So these flowers from this tree are a good reductant, so it reduces the compound, the palladium compound, into nanoparticles which can be used for catalyzing, actually. Sorry. Where should I go? I touched the wrong one. No problem. It's okay. Okay. I don't expect all of you to relate to this, but I just have to go through some slides to show how the chemistry is done. And one is first of all, is to reduce the palladium compound, which is palladium-2, to palladium-0. Now, you have to characterize these nanoparticles. You want to know what the size is, but that doesn't involve many of us. But what we have to know also is the distribution of the size of particles, how big are they and how well are they distributed, because if they're uniform in size, it's helpful to know that. Then the next thing is to know whether they can catalyze the reduction. We have chosen one dye only, and I want to explain why we used only one dye. And that is, when we do analysis of water, there are complex mixture. Many things are in the water, but if you get water from the dyeing industry, you know the dye and the salts that they use to promote the dyeing process. It's called a mordant. So the mordant is a salt. So the salt is there, the dye is there. So what we do in our kind of analysis, we take pure water, we add the dye to it, and we do the analysis. Then we know that the method works. And then we apply it to a real sample, that is a sample that contains the dye from industry. So if it works for a pure sample, for a sample that we made up, and it can work for a sample which we get from industry. So that is the idea. So in conclusion, I want to say that the method that we are using is promotes green chemistry. That is, we don't use chemicals that can cause more pollution in water. And we use nanoparticles from reduced from metal, but the metal is only used there as a catalyst, and we use a chemical which is innocuous, that is not harmful to the water system, to get the water, the dye reduced to something else that is degraded. So basically what we do is we do not take out the dye. We do not remove it by adsorption. We reduce or degrade the dye to something that is less harmful than the dye itself. So thank you for your attention, and I hope something got out of this, and that the analysis of water is a complex, very complex process. All the aspects need to be known to put together a comprehensive method for analysis. So, but each method has to be well documented, well researched, so that the total number of methods that one uses can work in a proper way. Thank you very much for your attention.